Liquid cooling may make your computer quicker, quieter, and more visually appealing. This is how it works. When your CPU becomes hot, instead of immediately cooling it with a fan, you add a water block, a liquid pump, and a radiator. Cold water is injected into the water block via the tubes. The heat from the CPU is subsequently absorbed by the water. Water has a larger heat capacity than air, so it can absorb a lot more heat before it warms up. The heat is then transferred to the radiator, which is so effective at dispersing heat that the fan doesn't have to blow very hard to keep the water cold. This is why liquid-cooled PCs are often quieter. Now that the water has cooled down, it is returned to the water block, and the procedure is repeated indefinitely. In actuality, all of the pipes are fully filled, and the water circulates and mixes so quickly that the entire loop reaches a constant temperature. So, what makes the radiator so effective at cooling water? The radiator, on the other hand, has many small fins that absorb heat from the water and then dissipate it into the air. The greater the number of fins on your radiator, the faster it will cool. Because you have a large surface area exposed to the elements. It's the same idea as chilling a hot drink. Crushing ice into little pieces can chill your drink faster than a single large piece of ice. This is due to the increased surface area for heat transmission. As a result, the colder the water will be, the more radiators you have and the quicker your fans blow. And the colder the water, the simpler it will be to absorb and retain heat from your components such as your CPU and graphics card. So, now that you understand how liquid cooling works, you should know what parts you require. You'll need the same components as a standard PC, plus liquid cooling components. You'll need a pump and reservoir, which are frequently sold as combination radiators, generally one for your CPU and one for your graphics card fans. Water blocks for your CPU and graphics card tubes, with compression fittings that may be firm or flexible to link the tubes and liquid. This might be distilled water or something more elaborate with UV reactive coloring and antibacterial agents. I hope you found this video useful in understanding the idea of liquid cooling.